going to look at some specific examples of non-parametric tests, and we're going to look at what we do if we have matched pair data or single sample data. So the sign test is the first one we're going to look at in 13.2 is the sign test. The sign test is a non-parametric test that uses the pluses and minuses to test the different claims. Okay, so it involves matched pairs. It can involve nominal data, even though we're not going to look at it in this class with nominal data. And it can test claims about the median of a single population. We're just going to do the first two. The matched pairs and the median. We're not going to do the nominal data in this class. The requirements are the sample data needs to be randomly selected, and other than that, there's no requirement for this data. The Minitab procedure is we enter the values of variable 1 into column 1 and the values of variable 2 into column 2 if we have matched pairs data. So if we have a before and after, or we have an example in the homework with two different times for temperatures to be taken, then you're going to need to create a column 3, which is equal to C1 minus C2. If you're using Minitab 17 or 18, you go up to Calculator, you enter C3 for store results in variable. Then in the expression box, you enter C1 minus C2. Click OK. Then you go to Stat, non-parametric, one sample sign, and you enter in these differences. So you're entering in the C3 only, not the C1 and the C2, just the C3, the differences. Then you click on Test Median and you enter 0, because if there is no difference, when you subtract them, the difference should be 0. Then enter in the appropriate value for the alternative hypothesis. Maybe if you thought C1 was greater than C2, then C1 minus C2 would be greater than 0. If you thought that C1 was smaller than C2, C1 is less than C2, then you would have said that it's less than. And if you just think they're different, then you would choose your alternative to be not equal to. Now let me say Minitab procedure if you're using Minitab Express because you have a Mac. I am aware that at least in the Minitab Express that we used last year with Minitab 17, the Minitab Express for Mac did not have the calculator to do the subtraction for you. So the students had to get a calculator out and do all those subtractions themselves. Because of that, I only assigned 1 or 2 problems that you are doing matched pairs, and the data set is only about 10 values long, because those of you with a Mac and using Minitab Express are going to have to calculate those differences by hand. So you're going to take the sample point in sample 1 minus the first one in sample 2, enter that difference into Minitab. And then after that you'll do it the same way. Here's another example. If we look at the example on page 567 that deals with weights in September and weights in April. I do see that I misspelled weights for September. So you enter the values into C1 for September weights, C2 for April weights. Then you go to the calculator and you create the difference. Then you go to non-parametrics, one sample sign, you enter C3 in as your variable. Again, we're seeing if there is a difference, and all we're wanting to know is, are they different? So the alternative is not equal. When we do this, the sign test tells us we have 10 pairs, 7 are below 0, one of those pairs are equal to each other, and 2 are above. It tells us our p-value is 0.1797, which is certainly greater than 0.05. So we fail to reject the null hypothesis. There is not a significant difference in the weights between September and April. Sample sign test. Now the one sample sign test, whether you're doing Minitab Express or Minitab 17 or 18, it is the same procedure. You're going to enter your values into a column. Then you're going to go to Stat, non-parametrics, one sample sign. You enter in the claimed value of the median. Suppose where our claim is that the values are, the body temperatures are less than 98.6. So then your claimed value for the median is 98.6. You enter in the appropriate alternative hypothesis that would be less than. And in this case, remember, notice in here too, in all of chapter 13, I am never talking about the mean when I'm talking about my hypotheses. All of these hypotheses are dealing with the median, not the mean. So for example, we had 106 body temperatures. It is called body temp. It's on the data sets that I put on the portal for you, or you can get them directly from www.triolastats.com. You're going to enter the value of the median to be 98.6, and our alternative is less than, because we believe that these 106 body temperatures, the median value for these 106 temperatures is less than 98.6. When we click OK, our results say that we had 106 values, 68 were below, 15 were equal to each other, and 23 were above. And that meant that since it was less than, and we had an overwhelming number less than 98.6, we had 68 of them less than 98.6, that gives us a p-value of 0, which is certainly less than 0.05, so we reject the null hypothesis. There is enough evidence to support the claim that the median body temperature is less than 98.6. Better test when you're dealing with matched pairs is the Wilcoxon signed rank test. Non-parametric tests often use the ranks of the data instead when we're looking at matched pairs. We're just seeing, are they above or below each other? Now when we test the null hypothesis, we're always testing the population of differences has a median of 0. So the null hypothesis says the matched pairs have differences that come from a population with a median equal to 0, versus the alternative, the matched pairs have differences that come from a population with a non-zero median. Now with the data, we remember that the requirement is it has to be matched pairs, and other than that, all we need to know is that the distribution is approximately symmetric about the median, but it doesn't have to be normally distributed. Let's consider the sign test, which we looked at in 13.2, and now the Wilcoxon signed rank test that we're looking at now in 13.3. The sign test only considered the differences, whether the differences were positive, negative, or equal to each other. But it did not consider how, if there was a difference between them, how much difference is. Wilcoxon signed rank uses the magnitude of the differences, thus it is a better and more powerful result. Sign test only says that those two values were, that sample 1 had 68 below 0, that the difference was below 0. So it didn't distinguish between whether it was a difference of 1 or was it a difference of 20, whereas the Wilcoxon signed rank would consider the magnitude of that difference. They would consider if the two values were different by 20, would be more different than a difference of just 1. So if you ever have to choose between the sign test and the Wilcoxon signed rank test, you always choose the Wilcoxon signed rank test. So gives you more powerful results. The procedure is almost the same as with the sign test. We have C1, you put variable 1, C2, you put in variable 2, and then you go to the calculator and you calculate a C3 doing C1 minus C2. Again, for those with Minitab Express, I am aware that you don't have this calculator, so I kept the data sets to be no more than 10 pairs and only 1 or 2 problems that you have to do this by hand, do this difference by hand. But just know, I just want you to get aware of this type of test. To do it, you go to Stat, Non-Parametrics, One Sample Wilcoxon. You enter in that difference column, column 3. You click the test median, enter 0 if you're comparing two pairs, right? And select the appropriate alternative. Maybe you think median 1 is less than median 2, median 1 is just different from median 2, or median 1 is greater than median 2. So for example, let's go back and do the same example we did a minute ago with the September and April weights. But this time, let's do the Wilcoxon signed rank test, the one sample Wilcoxon, which now we get a test statistic of 5, the p-value of 0.044, which is less than 0.05, which means we reject the null hypothesis. There is enough evidence at the 5% significance level to suggest there is a difference between the weights. Okay, now this time there was a significant difference last time there was a significant difference, but we got that the p-value was 0. This time it's not really 0, it's really 0.044. because this test gives us more powerful results. So these are better results. Said that it was less than 98.6, or alternative was less than 98.6. The median value was 98.6, and we could get the different results. That's the end of the lecture on 13.2 and 13.3. They covered non-parametric testing of either matched pairs or one sample. That's the end of this lecture. We're going to continue on in the next lecture with 13.4 and 13.5.